start with the quiz.
All right. Ugh. Look at this beauty.
Okay. I'm gonna put it in white.
So, seems to be 3 miles per hour in the west. When you leave.
Okay, so number 1. You want to swim from one side of the river to another side. So your speed is 3 miles per hour in the west direction with negligible water velocity. When you reach a certain point, you will encounter water flow with a velocity of 6.2 miles per hour in the north direction. What is the resultant speed and direction?
That's just a vector, right?
Yeah, so you
Yeah,
have like
it's gonna be
the north.
on the south. Wait. Oh yeah, she's right. It is north.
Yeah. Well, when we draw the picture, it's gonna have like the one arrow pointing north, and then we draw the other arrows, and then we put in the angles or the length for one.
Yep.
Yep.
That real good stuff.
Okay.
All right. Let's see what we got.
So
So we just have to do like 3 miles per hour squared and 6.2 miles per hour squared, right? And then get the square root of that or something like that.
yeah, the a squared plus b squared, right? Under
Yeah, I
the
think so.
square root.
Yeah, it's the square root equals r.
So it should be like 6 point. Is it? Tell us to round.
Um.
Oh, just do 6 6. So it'd be like 6.9 miles per hour. I'm guessing. Resultant. That would give us our speed.
Yep.
Yeah.
Speed west.
0.44. Yeah, at 6.8. Or actually 6.9, since we're gonna round.
Yeah, if you round up, I got that too. So I'll put the equation in.
So we just need to find the angle direction.
Yeah. Alrighty. So. So inverse cosine of, let's see here. Let's see.
So it's going to be sine and cosine. Heck? Okay.
So we can use those speeds as, let's see here.
Yeah. I'm trying to think. Back to this. I swear we had a problem.
We can turn those into points, right? Like, because they're heading west, it would be like 3,0, and then because the water's heading north, it would be like 0,6.2.
Yeah. Oh yeah. I think about that. I'm sure we could trying to remember. I feel like I was just doing problems like this. I just went blank. But yeah, I'm sure.
I'm not 100% sure on that. But
Me either. Let's
I'm looking
see.
at the book right now.
Yeah. Same.
Yeah, I'm looking in the book.
I'm gonna go look at my notes too. I know I have it in my notes somewhere.
Use sine and cosine to find the direction angle.
Actually, if we do it like the horses,
Uh-huh.
so like the 300 pounds of force and the 200 pounds of force,
Uh-huh.
we should be able to do it that way, right?
Yeah.
Okay.
So we know that it's 90 degrees because it's north and west.
Yep.
So we can do like sine of theta over, it'd be like 3, and then sine of 90 over, that would be over our 6.9,
Yeah.
I think.
Sine of 3. Sine of 3. Hold on. This will be sine of B.
Looks like 25.8 degrees.
So how did you actually get that?
So I did 3 times sine of 90 degrees divided by 6.9, and then that gave me like 4.434 long number, and then I did the inverse sine of that to change it into degrees, and so that should be the angle. That would be the short side, closer to north, because north is pushing harder.
Yeah.
Okay.
So it'd be closer to the 6.2 rather than closer to the 3, because that's pushing harder.
Mm-hmm.
So you'd be facing more downstream.
Oh yeah, yeah. I think I know what you're saying.
But because of sig figs, I think it would just be 26 degrees rather than 25.7.
Yeah.
Because they only use 2.
Mm-hmm.
Yeah.
Yeah.
They were all saying 26 degrees.
Mm-hmm.
Okay.
Nate, it's your favorite one. Number 2.
Do you not like these ones, Nate?
No, he was only. I couldn't figure it out. What was
Oh.
that, Tuesday?
Okay,
Nate
because
figured it out.
I winged it. Okay, the teacher messed it up, and I was angry because it was not in the assignment or the book. So I was mad.
Somehow he figured it out. Anyways.
That's because it was easy. Oh.
Sure, makes me feel bad.
Oh, now this one got tougher. Okay.
Okay. So, rewriting the rectangle.
Right?
Yep.
Polar equation for r equals 10.
So this is going to be that y equals, right?
Yes.
Yes.
And then this one has like extra stuff though.
Oh.
Okay, so
Somehow you convert it back to X and Y, I think.
Yeah.
I think there is one example in the book, but I will find it.
I'm pretty positive.
I think check 9.2 because I know they have it.
Yeah, it was on the second assignment.
9.2.
Yeah, check 9.2.
Okay.
Wow. Look at this beauty.
I think I know what I need to do. Okay.
Be back in a second.
Well, I don't know now though. Maybe we'll just put R again. But because it has 3 this time. It would be negative 7x plus 5. But then we have to put the 3 in there.
Sorry about that.
So
Wait.
I don't know if it would
7.6. Polar equation.
Write an equation for the what? Fetch.
Yeah. We did this in the homework, but we went
Yeah, we did
we
this.
went forward.
Yep. We did this in the homework assignment.
Mhm.
Oh crap. Probably Kayla's gonna beat me in the punch.
So yeah, we're converting it to like I equals X equation.
Oh, okay, now that made sense.
But you said the none.
But the problem is there's 2 on the bottom.
Yeah.
So I don't know if she just wants us to put R equals in this case and then do X and Y. Or I don't know what we would put 3 with. Unless we put 3 with R.
Yeah.
That would be weird. I feel like.
We're gonna have
So sine is Y, right?
Sine is Y.
and cosine.
Oh, wait a
We're gonna have
second.
to
It would be 3.
We're gonna have to divide it out.
Yeah.
Yeah.
So
First thing, we're gonna have to times both sides by 3 sine theta and 7 cosine theta.
Okay. So we're gonna have all that equals 10.
Yeah.
Okay. Okay. So we're gonna have sine cosine r equals 20. And then let's see where we're gonna have.
And then we put the r's into it. So it'd be 3r sine
minus
minus 7r cosine theta
equals 12.
equals 10.
Oh, sorry. Oops. Sorry.
And then we can add 7r cosine to both sides. We would just
Okay.
have 3r sine theta equals 7r cosine theta
Plus-
plus 10.
Okay.
And then we'll just use our r's and cosines and all that good stuff. And so we'll have 3y equals
I was gonna say
7x plus 10
plus 5 or plus 10.
plus 10. And then we'll just divide both sides by 3.
Right.
So I think it's just y equals 7x plus 10 divided by 3. And then I don't think you could simplify that much more.
No,
That's all you could do.
that's all you could do.
Nothing is
'Cause it would just be-
by 3 up top.
Yep. So I think that's what she's asking for, right?
I'm pretty sure. That
I'm
would make,
pretty sure, but it could be he's asking for I was doing it correct.
that would make sense.
So-
to me. The only other thing I could think it could be would be 3 equals negative like 7x plus 5 or something. But we went backwards like we're supposed to, so I feel like this one is a little bit better.
Because in the book it says for each rectangular equation, write an equivalent polar equation,
Mm-hmm.
and the rectangular equations are y equals like 3x minus 2 or x squared plus y squared equals 9.
Okay,
Yeah, exactly.
exactly.
I'm assuming the y equals is the base form, but
It
let me
is.
continue on in the chapter a little bit, and
Ooh.
it doesn't tell you the other way.
No, but no, it is the base form. So
So, like, possibly you could have left the x on the other side,
Yeah.
but then it would just be weird because then it would be like 7/3 x,
mm-hmm.
or 7 divided by 3x, because you would have divided by both sides.
Oh yeah.
Yeah. Okay. Ooh. Okay. Number
Oh, dang.
3.
Oh. Dang.
Right. The polar equation. Right. An equivalent polar equation for the rectangular equation. X squared plus y squared equals 9. Y over x squared.
So that is r squared equals 9
And yep.
y divided by x. And I don't think we can do much with the y divided by x.
I don't think so. Because
Because even though they're squared, it doesn't actually give us anything that we can manipulate. We could put sine and cosine in there, but I don't think that would help us any.
No,
Oh,
it
that's funny.
wouldn't.
But
we
they
just
want it
have-
with what?
yeah,
I think they want it with sine and cosine, don't they?
most likely.
So r squared equals 9
9.
r times sine theta all over r times cosine theta square rooted. Dang. And I don't think we can get rid of the square root because you have to figure out what cosine and sine are.
Sine R. Mm-hmm.
But since you don't know.
You can square root. Unless there's some trick in the book, but I haven't seen that.
I haven't seen it either.
Me either.
So I think that's about as far as we can go with that one.
Okay. Because I didn't want to get that wrong. Because we don't want to get that wrong.
Yeah.
Because then it would just be, yeah. Let's see.
We could take the square root of everything and just make it r, don't we?
Yeah, that's what I was thinking. We could do that.
Okay.
So that would mean it would be, what, 3, or r equals 3,
Mhm.
and then just sine over cosine.
Yep.
Well, I guess because it's divide, the r's would cancel out, right? And it would just be sine over cosine, right?
Uh-huh.
Yep.
So I guess we can manipulate that close further. Sine theta. Can we times the 3 without? I don't think we can, eh?
No, the
No.
The
That
three-
would cancel out.
No, we can't.
So, did you write the final equation as r equals 3, parentheses, sine divided by cosine?
Yeah.
Okay.
And then this one, oh my goodness. This one is really not that bad, but I was so tired when I was doing it. It was very frustrating to me for a little while, but I got it.
Nice.
Okay,
Nice.
so we need to write the other polar coordinates for 4 and 4 pi over 3. So, oh goodness. Okay.
What the
heck?
What the fetch?
So what we do, how we want to, oh, okay. So how we want, let me pull up my notes and put where we want to start.
Okay.
Okay. So, oh yeah. So this is pretty much what we're doing. X, so our new x coordinate is going to be x equals 4 times cosine of 4 pi thirds. So we just find 4 pi thirds on the unit circle.
Okay.
So, times it by whatever that is. So it ends up being -2 for our x coordinate.
Okay.
And then,
Oh, because it's 1/2, right?
yeah, sorry. I didn't say that.
Just ending in the 1/2. Okay, I got that now.
Okay,
I'm catching
yeah.
up.
And then sine of 4 pi thirds is -√3 over 2.
Uh-huh.
And then that one is kind of tricky because I was like, wait a second. But in the end, that's going to be -2√3. That's our y.
Wait, do you times the 4 pi thirds times
Yeah,
pi
let
thirds?
me- yeah, so what you do is you go 4 times sine of 4 pi thirds, so it ends up being 4 times sine root 3 over 2.
Okay.
Okay.
And you get that 3.404, whatever.
Uh-huh.
And then if you go to root 3, it's not the exact. They don't match exactly.
No.
Which I don't. Oh wait a second. I just missed. But they still don't match exactly, but they're close. So my guess is that's why they put that. Because I think that's what was throwing me off. Was I was like, well, they don't match up, but none of them really matched up. They were all just kind of close.
Nice. What Kaylor's quote is nice.
Alrighty.
So our new coordinates are -2, and then -2 root 3.
Okay.
Okay.
And that's the answer.
How do we find 2 other polar coordinates?
Let's see.
Did he explain it in the book?
That's what I was just looking for.
Yeah, because that's one way. I don't know.
What the other way is.
Unless maybe you do. Nope. That would give you the unless they just swapped them around for some reason, and did x equals 4 times sine and 4 times cosine. I don't know, and y is 4 times cosine.
I'm not seeing anything about that.
But yeah.
Because we're all probably going to all draw it.
Actually, what if we reflect it and use the other end of the unit circle that's that same line? Is that what they're talking about?
Yeah, we could.
Yeah, okay.
So it would be +2?
Yeah.
Instead?
Mhm.
So it would be +2 and then positive.
2 pi thirds.
I don't remember. 2 pi thirds. Because that's
not 2 pi thirds, 2 root 3.
Yeah. That's like what?
Wow. Sorry.
Because pi thirds and 4 pi thirds are the same thing.
Yeah.
Only just like reflected, like it's the same line. So I wonder if that is what they're talking about. Name 2 other polar coordinates that are located in the same place.
Yeah, that would
make sense. It says the same place, but that doesn't mean the same line.
It could be a different line.
What the heck?
Where coordinates a single point. How are the coordinates not unique?
Ooh. Oh. Give me a question.
It doesn't make any sense how they figure that out.
No.
Let's see.
See if I can find the answer in the book.
A single point. However, the coordinate is not changing.
The only thing I could think is if they maybe ended up doing the x would be 4 times sine, and y would be 4 times cosine instead of what we just did.
Yeah.
That would just flip the coordinates around.
I mean, that could be it, but
Let me see. I'm looking.
feels like mostly in the book it explains there's only going to be one.
Yeah.
Are you looking in the book, Kaylor?
I'm reading the definition of polar coordinates, trying to figure out.
Okay. Probably going to go there too and see what's going to. Oh, okay. Oh, yep.
Okay. So any coordinate that has so pretty much it's like anything, any of the quadrants that have the same type of radian. So like pi thirds, 2 pi thirds, 5 pi thirds are all the same. They're all the same point.
Uh-huh.
So it uses the example 2 comma pi fourths, and so it says negative 2 pi fourths or negative 2 pi fourths to 5 pi fourths to negative 3 pi fourths are all the same point. So pretty much we can just play with any of those.
Yeah.
Oh, okay.
According to the
Yeah.
According to the book.
So should we just use pi thirds?
I think we can just use pi thirds. So it would be let's see, we're negative 2 right now or positive 2?
So our first answer was negative 2.
Negative 2. So that would make it positive 2, right?
Uh-huh.
Mm-hmm.
And then if we use 2 pi thirds, that would make it negative 2, but positive the y coordinate. And then if we use, well, that should be enough actually. We only need 2.
There we go. Got it.
So what we're going to have?
So it would end up being 4. So for x, it'd be 4 times cosine of pi thirds, which is 1/2. And then 4 times sine of pi thirds, which is positive root 3 over 2. For the y, you just multiply those and you'd get your answers.
Okay. I
Sweet.
didn't know there was another way. Huh.